Hello guys, welcome to my channel. In today's video, we're gonna talk about force. Okay, so what's force? Force is every push or pull. And you can describe the force exerted by using an arrow. And the combination of all forces acting on an object, we call that as net force, like this. Let's talk about friction. Friction is a force between two objects in contact. And friction depends on two factors. First, how hard the surfaces pushing each other. Second, what surface is involved. The friction that acts on an object that are not moving is called static friction. Sliding friction occurs when two solid surfaces slide over each other. When an object rolls across a surface, rolling friction occurs. Fluid friction occurs when a solid object moves through a fluid. Now let's talk about gravity. Gravity is a force that pulls objects toward each other, like this. Earth is pulling my pencil sharpener. And Newton said, every two objects in this universe attract each other, without exception. However, you can't feel the gravity between these two objects, because compared to the Earth's gravity, the attraction is just too tiny. And gravity depends on two factors. First, distance, and second, mass. Mass is a measure of the amount of matter in an object. Mass and gravity are proportional. But distance and gravity, they're inverse proportional. Based on that, we can derive the conclusion like this. And if we substitute the mass of the Earth, then we can get the gravitational acceleration. Now, let's talk about free fall. So, free fall is very simple. So, yeah, exactly like this. When free fall, the force of gravity is an imbalance force. So, it makes the object to accelerate. And it's constantly accelerate as 9.8 meters per second squared. So what if you think about the graph form of falling object, then it will form like this. Wow, you see? Time, velocity. So what's happening? Air resistance is constantly resisting to the force of gravity. It means this curve will converge to a certain line. And we call the line as terminal velocity.
Gravity immediately pulls her towards the ground, and she starts to accelerate downwards. But air resistance is acting in the opposite direction. The faster she falls, the greater the air resistance. Eventually, the upward force of the air equals the downward force of gravity.
From now on, we've talked about free fall situations, right? But what if you throw the object like this? Then we call it as projectile motion. So we can think like this motion is just x and y is divided. So x keeps its motion, but y, the gravitational acceleration, its gravitational force is pulling this to the ground. So it cannot go straight because of the gravity. So it would form like this. Now it's my favorite part, Newton's law. I highly recommend to watch my short video. Okay guys, now let's talk about momentum. Momentum is quantity of motion, but too abstract, right? So yeah, we're gonna see what is momentum by using our eyes visually. Here's our friend Ron, and this is Infinity Gauntlet. Ron punches this chair, then he cannot make that big force, right? Because it's too tiny and his force is just too weak. But what if I just punch it using this Infinity Gauntlet? Then, oh, Jesus Christ! Oh, what the hell? So yeah, we can see if mass is greater and velocity is faster, then we can make greater momentum and great stress too. As you can see, momentum, which is quantity of motion, is proportional to an object mass and its velocity. So if we make this as Formula: momentum is equal to mass multiplied by velocity. Simple, right?
Like this. And it does this.
As you can see, white ball's momentum transferred to blue ball's momentum. It means total momentum conserved. So the total momentum of any groups of objects remains same or conserved unless there is an outer force exerted. This is law of conservation of momentum.